Okay, so the first question, without using a calculator, do the following addition of rational numbers and look for the pattern. What is the pattern? So first of all, let's do this addition. So the first question here, we need to find a number that both 2 and 3 go into. The easiest way to do that is to times those two numbers together. So 2 times 3 gives me 6. So everything on this side, I'm going to times by 3. And everything on this side, I'm going to times by 2, okay? So that would mean I've got 2 times 3 gives me 6, and 1 times 3 gives me 3, okay? Plus everything on here times by 2. 2 times 3 gives me 6, and 2 times 1 gives me 2. So this looks like a much easier sum to do, all right? We know that when it's both the numbers have got the same denominator, we just add those two together. So we've got 5 over 6. Not a fantastic pencil. Oh, could you see that? The second one, 1/3 plus 1/4. Sorry, I'm not very skilled at doing this all at the same time. Now, the number that the 3 and the 4 both go into, an easy way to do it is to times them together. 1's 4 is 4, 2 4s are 8, 3 4s are 12, okay? So both of these numbers go into a 12, and we get that by timesing this group by 3 and this group by 4. So we would end up with everything in here times by 4 leaves us with 4 over 12. And timesing everything on this side by 3 leaves us with 3 over 12. Again, this sum looks much easier, and we can all see it's going to be over 12, and 4 plus 3, 5, 6, 7. Okay, nice and easy. Let's have a look at the third one. If you feel like watching me, you can do this one by yourself. Feel free to pause it and have a go. So again, we're looking for a denominator that both these numbers will go into, okay? So the easiest way is to times this lot by 5 and this by 4, okay? So 1 times 5 is 5 over 4 times 5 is going to be 20. And 1 times 4 is 4. 5 times 4 is 20, all right? So then we're going to end up with 5, 6, 7, 8, 9 over 20, all right? Now let's see if we can see a pattern, all right? I'll give you a chance to pause that and have a look and see if you can see the pattern. All right, some of you might have noticed that these two numbers here together added up give me this number, and these two numbers here times together give me this number. Let's have a look and see if it works for the second one. So 3 plus 4 gives me 7. 3 times 4 gives me 12. So far, so good. Let's try again. 4 plus 5 gives me 9. 4 times 5 gives me 20. I think that is our pattern. Now, using mathematical language, okay, when we add things together, we call it the sum of, okay? So we're calling it the sum of, and this number is called the denominator because it's the lowest number. The sum of the denominator. All right. Now we said that the bottom number was these two numbers times together. Okay. Times in mathematical language is called the product. So we're calling that the product of what? The product of what two numbers? Again, the two bottom numbers, which are called the denominator. Now, if you wrote bottom numbers added together, bottom numbers times together, that's still correct. You've still got the same answer, okay? What this just means is that it's given you it written in mathematical language, okay? Let's have a go at the second one. Now, the only difference here is that instead of addition, we've got subtraction. We still need to do the same thing, okay? So I need to find a number that both 2 and 3 go into, and we already know that the common factor they have, okay, the number they both go into is 6. So we've got everything in here being times by 2 and everything in here being times by 3. So we're going to end up with 1 times 3 is 3, 2 times 3 is 6, minus 2 times 1 is 2, 2 times 3 is 6. All right? So we know our answer is going to be over 6. 2 take away 3 leaves me with 1. Okay, cool. Let's have a look at the second one. Now, a number that both 3 and 4 both go into is easily found by timesing them together. 1's 4 is 4, 2 4's are 8, 3 4's are 12. So everything here we're going to times by 4 and everything here we're going to times by 3. So 1 times 4 is 4, 3 times 4 is 12, take over my minus, and then I've got 1 times 3 is 3 and 4 times 3 is 12. Okay, and then I've got a much easier sum to do. 4 over 12 minus 3 over 12. Okay, if I've got lots of 12 and I've got 4 of them and I take away 3, you'll know I'm left with one lot of 12. Now, I can already see a pattern going on here. 1 over 6, 1 over 12. Now, how are they getting the 6? Last time we looked at that number, we were getting it by timesing the two numbers on the bottom, the denominators. 2 times 3, is 6. That looks pretty true. 3 times 4 is 12. So that looks pretty true as well. And it seems every time it's a 1. So if we were going to estimate what our answer is going to be here, what do you think that might be? All right, let's do it. So this one here, again, we're going to times everything on this side by 5. And we're going to times everything on this side by 4 to get the same denominator. So 1 times 5 is 5 over 20 minus 4. 4 times 5 is 20. Okay. And you can see this is looking good. 5 take away 4 does give us 1. So the pattern that we can see there, okay, it seems to always be a 1 on the top, and it seems to be the product of the denominators, or these two numbers times together again, every time on the bottom. That is our pattern. Okay, good job.